Right. I just need to convince Haza and anyone else of a fact here, okay? So, right. No, wait. Okay. So, right. Here's X. X is 1, 2, 3. And here's Y. Y is 1, 2, 3. Okay, fine. All right. And then here's XY. And XY is 1, 4, 9. Okay. So, SX will be 1 plus 2 plus 3. And that's 3, 4, 5, 6, isn't it? Okay. SY is 1 plus 2 plus 3, which equals 6. Okay, fine. Okay, so far so good?
Yeah.
Okay. SX times SY equals?
6 times 6, 24.
No,
Try again.
6 times 6.
24.
Yeah, try again. 36. 36.
Oh.
Yeah, okay. Right, fine. Right. Now, XY is 1 plus 4 plus 9, which equals 14, which is not the same as this.
How?
Are you convinced?
Numbers!
Magic.
Magic, yeah, magic.
Because the same as
So, sorry, you're saying that 14 has to equal 36?
Yeah.
No.
Oh.
That's a new math formula.
It is, isn't it? Yeah.
X is Y
I said
times.
bro, this is wrong.
But I just...
It's by Albert Einstein.
I have a question.
He's not convinced. He believes that SX, SY has to equal SXY.
I think we should blame people as ours their way of seeing it.
Logically, 6 times 6 is equal to 36.
Okay.
Yeah.
1 plus 4 plus 9 logically equals 14.
What is confusing you? What's confusing you?
The SXY, right?
Yeah.
So it means the SX times.
No. SXY means you total of X times Y.
Okay. The total, the total.
No. X times Y.
Ah, yes, okay.
149.
Oh. So this, like, the XY is like a different thing.
Now, I'm not going to talk about this again, Haza, right? Because that's the second time now. So the third time you ask me, I'm going to come over and just...
I have a question.
Yeah.
Page 110.
Yeah.
4.
What's 100? What's on 110?
It's not close. 4. I didn't know how to do it.
Which part?
All.
No, because it doesn't make sense that you can't do 4, but you're able to do the ones before it.
Yeah.
So what's different in 4 that you couldn't do? I'm not going to accept that you say you can't do it. Excuse me, I just need to squeeze right. What's different in 4? What part of 4?
Predict the value.
Okay, fine. So it's not all of it, just the second part, isn't it?
Yeah, but
Yeah.
like it's the most important thing.
Well, look, let's talk about the second part, predicting the value, okay? So, you remember what, I'm not going through the first part, which, actually you don't need to draw it, because I've drawn it, haven't I? And you can look at the graph, and you can kind of estimate, the C.
5.
Now, the problem with this graph, though,
Scale.
6.5.
the scale
Yes.
is not right on it. You see here? See, this is 3.5.
Yeah.
This part here isn't 0, is it?
Yeah.
In other words, this here is not actually the y-axis. The y-axis is further to the left. This is 3.5.
Yeah.
And then here's like 2.5, 2, 1.5,
Yeah.
1. So the y-axis is like over here.
Uh-huh.
So you have to imagine this going down.
Uh-huh.
So what you could do, it's not a big deal, because it's already drawn for you. You could take out your ruler and just extend it down. Actually, if you give me the ruler, I'll show you what I mean. How big is each half a unit? What's it, about a centimetre, is it? Roughly. So, and a pencil there. I'll show you here. Okay, so if I look at this, do you see how that's 1 centimetre? Okay, so if I go backwards, if I can fit it in, right, so that's 3.5. Okay, there's 3, 2.5, 2, 1.5, 1, 0.5, and 0. I need more paper. So the y-axis is like here. You have to extend that line down to it, so it won't cross it at 8. It'll be more. It's more like 2. So actually, you kind of do need to copy this in your notebook and extend it. Okay. So, anyways, the C is a little bit hard to see. Sorry, this is page 110, question 4. The C is roughly 2. Now the M is much easier to get. The M, you could take the top point here and the bottom point here, and you can work it out, and that's also roughly 2. You see here, the y2 is roughly 14, isn't it? And the x2 is roughly 6, and the y2. Yeah, okay, sorry, yeah, roughly this, and the y2 is roughly, I don't know, about 7, and the y and the x2 is roughly about 3. If I look down here and here, okay, roughly, so I get this. Okay, so now I have the formula y equals 2x plus 2.
How did you get the M?
Huh? The formula y2 minus y1 over x2 minus x1. Slope. Yeah.
Where is the value?
You have to read it yourself off the graph. Say again?
Must it be this and soon? And must end it soon because the graph is not really clear.
Yeah, this is what I'm saying. Like, I mean, I expect slightly different answers from people. Yeah? Continue?
Yeah.
So, it says now, predict the y value when x is 7. So you just say, what is the y when x is 7?
Okay.
16.
14, 16.
Yeah, that's all.
Okay.
So can we take like any point from the graph?
So it doesn't matter which part.
Not for this question. But in the next lesson, you know, we learned how to calculate the line exactly. Yeah. What's wrong? Now, there is another look. If you don't want to do what I did with the graph, okay, if you want to be a little bit more precise perhaps, another way to get the line is like follows. You say y equals mx plus c, and you sub in 2 points, okay? So look at the graph and pick 2 easy points to read on the line, not the dots, on the line. So if you look here, let's start with 3.5. No, let's start with 4. No, 4 is a good one. When x is 4, what's the line's value? It really looks like it's about 10, doesn't it? I think so. Would you look at it? It goes up.
It's close to 10.
Where's that then?
Alright, what do you want to say then?
9
I don't care, I'm saying it's 10.
5 and
Five.
11. 5 and 11.
5 and 11.
Yeah.
Okay, fine. 5 and 11. And then, I'm not so sure about these points. And then what you can do is you can sub this in. Okay? So if I sub this one in, I get 10 equals 4m plus c, don't I? Isn't that right?
Yep.
10 is 4. And when I sub this in, I get 11 equals 5m. Now, this is a simultaneous problem, isn't it?
Yes.
So you can just subtract.
Yes.
1 equals 2.
Now, you get here m equals 1, which is obviously, okay, so,
1 equivalent.
yeah, which is obviously wrong. I think whoever gave me the first point here didn't do a good job of it. So you can solve this to get m and c. It's not quite 10. Maybe it's 9. Let's say it's 9. All right. So if I subtract here, what do I get for m?
1, 4.
What do I get for m?
2,
2.
2, 1. 2, 1.
Yeah, and c is 1.
Yeah, 2, 1.
No, don't worry. I'm not so concerned about being precise right now. I'm just trying to show you the method, okay? So anyways, you can solve for m and c by using 2 points on it. Maybe you prefer doing it this way. Yeah? Okay, what's next now, guys? Histogram. What's wrong with histogram? It's easy.
No. You know how to make it.
100, page 100,
Yeah?
number 15.
We did this one
15.
on page 100.
Huh?
We did this one, didn't we? Oh no, sorry, I was thinking of it.
Oh.
No, we didn't do this one. Okay. Right, page 100.
Yes,
Yeah.
I wanted this.
Really? All right. Okay. Page 100. Question 15. The probability of being born with illness X is 2%. The probability of being born with illness Y is 3%. The probability of being born with both illness X and Y is 1%. Probability of X times the probability of Y, 0.02 times 0.03. What's that? 0.006, isn't it? So does PXPY PXPY, does that equal PX and Y? Well, is this number the same as this number? No. So are they independent? No. Are they independent? No.
Why? Yeah, yes.
You need to spend 5 seconds before opening your mouth, okay? Just 5 seconds, and then you can say something. Right. Right, what's next?
Best fit probably.
What's wrong with this?
If you get like the bounds.
Oh, don't worry about that. Doesn't have to be matching it.
Then I got nothing.
Did we do exam questions last week?
No.
No, we didn't.
Let's do some.
Yeah, because I did exam questions with the other group. So we did a probability and statistics question last week. So it might be good if we then practice one this week.
Yeah.
It's actually a good question in the exam. You know, you do a tree diagram, you do a probability, and maybe you draw a histogram or
Venn
maybe
diagram.
Venn diagram or something like this. It's actually
5 marks.
a good, no, it's section B question.
Uh-huh.
So we'll have a practice. Yeah, we'll have a practice of one.
Okay.
Let's open up. If you want to open it up on Moodle, we're going to open up last year's exam. Let's see what that one was like. The semester 2 exam.
Well,
We're not
semester
gonna-
2 exams, section A is 80%.
No, no, it's like 40%. let's have a look.
Let's check.
Look, why are you questioning me? You know, I've been teaching here for like over a decade. I know I think section A is not 80%.
Maybe.
Wow. Wow.
No, it's not.
Right. Maths for science.
Yes.
Which version?
Let's go with whatever, if there's a version 1 or something. Can you see 17, 18? Yeah, 17,
Different
18.
students.
Just the other thing for, let's see, version 1. Let's see which should be good to do here. Okay, so let's see, section B. So that's algebra, sequence and series, trigonometry, calculus. No, not this one because they. Well, we could do it, but we just have to skip a part. Let me just check version 2. Yeah. So in version 2, okay, you should be able to do the question fully because part A looks like it's about, can you see what it's about? 3 diagrams, probability. And part B,
Standard deviation.
they get you, no, part 3 is they ask you to get the regression line. And part C, Venn diagrams. Can you see that?
The what line?
Okay, I'll give you a couple of minutes to try this and then give you the answer. I think you should find it easy. So this is version 2.
Oh, version 2.
Come on, get started. In the exam, you know, you can take 15 or so minutes, but this is so easy, it should take you much less.
Yeah. 10 minutes, like.
10 minutes maximum.
Yeah, maximum.
Let me just, who am I missing from this group now?
Full house.
Yeah.
We got ratios.
Full house?
Full house.
Unfortunately.
But you say so probably.
We got Ray here, so
Yeah.
Wow.
Come on, Kirill, come on. Get working.
yeah.
Be nice. Now, how are we doing? Nearly finished?
Halfway.
No, halfway. Okay. Yeah.
I have a question.
Yes. Which part?
B2.
Yeah.
Is it sx squared or sx squared?
It's sx squared.
Sx squared.
Yeah. Or
I mean, is it square for the sx or square for the x?
what do you think?
For the x?
No.
No?
No.
Okay.
Because remember, we write that as sxx.
Okay. So it's the small s, right?
Yes.
Okay.
You have the formula for that.
Um,
You should have it in your notes. You have it in the formula book on Moodle, where you currently are on your phone. Come on, guys. English only, please. What part are you on, Hazza?
So x y.
Ah, no.
That's good. It's one plus. So now one plus x, right?
Say again?
One plus x.
Yes.
Not one times x. Or one square plus
Which part are we talking about?
b. Like to get the x squared.
Yes. That's what Kirill was asking me. So what do you think you do?
One plus.
1 plus? Why 1 plus? Why 1 plus?
No, I mean the x y.
To get the xy? Yeah, what do you do?
One plus y plus.
Y plus x? Plus? Do you mean multiply?
No.
Plus?
Oh, right.
Multiply, yes. Okay, 2 more minutes and then we'll have a look at the answer.
What is the Gershon line?
That's another name for line of best fit. Okay.
One more.
Oh, really? One more minute. Go, 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 go.
58.
It's not the sum of, it's the formula using. Yep. Exactly. The total of, yeah, the total of x squared, yeah, minus square. Okay.
Right, let's have a look. So the first one,
One more. Okay.
No, no.
oh, come on. A student has to pass through 2 sets of traffic lights on his way to college. So the choices are basically, well, let's see, what are we at here? Part A, part 1, okay. So you can either stop, go, stop, go, stop, go. The probability that he stops the first set of lights is 3 over 5.
Yeah.
So that's 2 over 5. If he is stopped at the first, then the second will be 5 over 8.
So 3 over 8. And the next 7 over 10.
And if he is not stopped at the first, then the stop to the second is 7 over 10, yeah? Like this?
Yeah.
Right, easy peasy. How many marks? 2. 2 for the first part. Find the probability that he stops exactly once. So that's stop, go, or go, stop, which is 3/5 times 3/8, isn't it?
5.
Yeah.
Oh, yeah.
Plus 2/5 times 7/10.
Yeah. 0.50.
0.5.
505.
Yeah, 5 over 50.5%.
No, 51.
No, she knows better.
50.5%. Find the probability that he is not stopped at the second set of lights. The probability that he's not stopped at the second set. Now, what that really means is,
Just we changed the 7 over 10 to 3 over 10?
well, no, I think not stopped at the second basically means go, go, or stop, go.
Yeah.
That means not stopped at the second.
Yeah. 0.35.
Is that what you get in the end, is it? Well, let me just write it down. Go, go is
3 over
2/5, 3/10, isn't it?
Yes.
And 3/5, 3/8.
Basically, that's what I said.
Yes.
Okay. Point
Points 3, 4, 5.
3, 4, 5.
69 over 200.
Okay. Part 4.
Ooh.
The student was in fact not stopped at the second set of lights. Find the probability that he was also not stopped at the first set.
0.6.
Well, hang on, let's see.
This is given that.
3 over 25.
Hold on. We want the probability.
Given that.
Yeah, find the probability that he was also not stopped at the first set of lights. So I'll write not stopped means he got go on the first. So I'll write G1. Given that, and what do we know here? That he was not stopped at the second. So that means he got go on the second. Okay?
Is it stopped? If it's not stopped, it's
Not stop.
Not stopped is go. Of course. Why didn't I think of that?
Not stop is go.
Yeah. Yeah. So we're all clear on how the word not works, aren't we? Yeah. Okay. Right.
No.
So we are not unclear on that anymore. Good. Okay. So we know the formula here. It's go on the first and go on the second, all over
Go.
go on the second. Now, when you look at that, we know what the go on the second is.
Yeah.
It's 0.345. Because that was literally, wasn't that literally the second question?
Yeah.
Go on the second.
Yeah.
Yeah. And we only need to get the top one now, which is go on the first and go on the second.
0.
So that's going to be 2/5, 3/10, isn't it? 2/5 times 3/10. Yeah, that's the only way to have. That's the only way to go on the first and go on the second is on this path. Isn't it? So, what would that be? 6.12, is it? Over 0.345. Yeah, is that right? 6
Way over 10.
is on the tree.
Ah.
You see, 2/5, 3/10. Go on the first, go on the second. So what do you get here?
0.347.
347?
348.
348.
8 over 23.
That's
Okay,
what I
very
got.
Yeah. Good. How many marks was that A part in total for that A part of that question? How many marks was it now?
10.
Was it?
Wow.
Oh, but I should tell you the exam doesn't total 100, so it's not 10%. It totals, they did it strangely, it totals I think 120, isn't it? Still, no, they did it, what way they did it? 24?
125?
I think it's 40. Section B questions are 20 marks.
Oh.
Yeah, 120. 120. I think
120.
I think they do it. I think they do. Is it like 125?
I thought 8% was
Oh, they made section 845.
Yeah.
That messes up the percentage.
8.2%.
Yeah.
That's it.
So it's 45 for A and 80 for B. So roughly speaking, it's like a 2-to-1. Anyways, the total's 125. So 10 is about 8% then, which actually is still a lot for this. Now the B part. What's nice here? Oh, okay. The first part is just to complete the table, so that's
527. Oh.
yeah. X squareds are
1.
13678 squared, so that's 19.
36. 49. 64.
Okay, and then the next one is XY.
5. 27. 72. 70. Yeah. And then
112. Okay. How many marks? 2 marks. Guys, come on. Part 2. Sx squared. Like this. It means the same thing as that, which is 225 squared, isn't it? Which is 625.
To the sum.
Oh my goodness. Would you not listen to the conversation I had with Karul?
How?
Don't tell me.
It
You
wasn't
did,
only me, so.
X is
Karul.
136.
How could
The
you
total of x squared.
Yeah, 2.
And the sum of x.
Small x. X.
No, it's small.
Oh, it's small x. I apologize. I apologize. For, look, do you blame me? All right. Yeah.
I didn't do anything.
I'm sorry. Small sx squared. Yeah, I know. Yeah, right. Okay, so that's what was that? That was sum
Of x
of
squared.
x squared over n, which in this case, whatever it was, a 5 minus basically the average of x, isn't it?
X squared.
Squared like that, isn't it?
Yeah.
So what did you get here over 5
159 over 5.
minus, and then the average is 5, 25.
Why 159?
What are you doing? What are you doing? What part?
The sum.
That's a minus there, not an equal.
No, yeah, I know.
You
So
said they
159.
don't add up to 159?
Yes, they do.
Really?
But this is 25.
Huh?
No, squared.
Yeah, I
Can you
squared
explain
25.
step by step?
Hasa, you'll have to explain this to her. It's not the same thing, is it?
No, it's not.
Very good, very good. Right, what is this?
34
That's-
or 5.
As a decimal, please.
1.127.
1 point.
1278.
Okay.
8?
What?
6.8.
What?
What?
Really?
Are you confused?
Wait, oh no, I square rooted it. So.
Ah.
Okay.
Oh,
Well, I don't need to square root because I have a square here, don't I?
Oh.
Yeah.
6.8.
6 point
8.
exact?
Yeah.
Yes.
Okay, and then what was the other one we wanted?
Small s x
Now,
times y.
Hasa, how do I calculate this?
It's not right question,
Tell me, Hasa.
We add the xy.
Yeah, so what do I write down?
XY.
Yeah, so what's that?
Gonna be
Yeah.
5
Yeah, good, yeah.
plus 20.
Ah, good, yeah, okay. Right, so what you get?
286. Oh, sorry.
So,
286.
Oh, no, that's big S, okay?
yeah.
Yeah, but we'll need that in a moment anyway. So what you get?
286.
286. Okay, so now
That's that short.
small sxy. What was that formula?
Total
Okay.
of x times y over n.
Yep.
Total of x times y over 5 minus average x times average y. Yeah. So that's 286 over 5 minus,
5 times 10.
what was average? Oh, it's 550, is it?
Yeah.
Okay. So what do you get for this?
36 over 5. 7.2.
7.2. Okay. Next.
Wait, go back. This?
Okay. But actually, you guys are waiting, so we'll have to wrap it up there anyways.
X, Y.
The next group.
Should we continue next?
Do you know, I think I'd like to finish this next tutorial. So you can, if you didn't finish it now, you can finish at home, and then we'll run through the answers.
Okay.
Sure.
I need to make it clearer the difference between big S and small s, so maybe I need to have like, this can be like big S, and this can be small s or something.
Cool. The big X is S in the sum, right?
Yeah, and the small one has the formula.
Yes.
Yeah, that's the same as that one.
No, but
Yes.
we already times it.
Four. 300. 200. Oh, additional.
Here, take your case back. Thank you.
Very good.